Welcome to LMS, Department of Collegiate and Technical Educations. So this is professional practice 5th semester. So topics on smart materials. Myself Venkatesh, lecturer in mechanical engineering, Government Polytechnic, Kerpet. So this is professional practice lab. So in professional practice lab, activity 1, how the information you have searched and that means you selecting a number of topics. They will be available in a syllabus. You'll be picking one. So means how you are the representation of the topics. Likewise, I am explained here the smart material. So overview of the sessions, I am going to teaching about introductions and classification of smart material, different types of smart material and application and conclusions. So here the introductions means smart materials are the material that can significantly alter one or more their inherent properties owing to the application of an external stimuli in controlled fashion. So you know that the mechanical in engineering field, the material you considering it's having some properties. So you know that the mechanical property, electrical property, or thermal property, or magnetic property, or like a chemical property. So likewise. So here the property inherent properties owing to the application of external stimuli. So external stimuli when application of the forces, the material positions under means either the tensile strength or stiffness or elasticity or compression strength get changes. So depending upon the whether the material will be ductile or brittle material likewise. So here the means due to the external stimuli inside the means inherent property of the material in our biological cells of the materials means the living cells of the material get changes. So by using external stimuli. So by stresses, temperature, noise, pH and electric field and magnetic fields. So it means smart means this very sensitive and clever and or wise what we say that is how it is sensitive then compared to for temperature or stresses or moisture or electrical fields or magnetic fields. So let us move to the next one. Here the classification of smart material. Here so smart material stimuli and response. How it responds depending upon the inherent property will changes. So are the means the what are the external stimuli is given to the material, it will changes the phase. You know therefore the shape memory material it will be temperature. Stimuli is nothing but a temperature. When temperature differences the material get deformed. Material get deformations. Similarly, another one is a piezoelectric materials. Here the piezoelectric materials deformation. You know that when application of the forces, the induced the potential difference will be occurs. Means nothing but electricity will be produced. So here the electrical changes are nothing but a voltage difference. We call it as potential difference. So and electrostructive. So potential difference here means the thing will have potential difference whether the material will be conductive. So we give the point means electricity or means the differencing of electricity or you get deformation. The material get deformation. So and another one is some magnostrictives. So here magnetic field. So stimuli is nothing but a magnetic field. So here the response is nothing but a deformation. So changing of the magnetic phases so are inside or the outside of the property of is the material. So here response is nothing but a deformation. Here the thermoelectric means nothing but a temperature. The name ends the name indicating the temperature. Thermo is temperature. So here the potential difference. So when the heating of the material or means in the cooling of the material whether the temperature will be differences, here the potential difference occurs. So photochromic means nothing but a radiations. Photo means the light emitted radiations. The color changes. So color changes. You know that thermochromic. Here also the stimuli is nothing but a temperature. So here the response is nothing but color changes. Here the shape memory materials. The shape memory materials, the name indicates shape memory means the regain its original shape. Regain its original shape. Generally we know that in the mechanical base, the one of the important property, elasticity of the material, means nothing but a passive material. We call it as all engineering materials is nothing but a passive materials, what we considering. So elasticity is the one of the important property. So when application of the forces, the material get deformed. So deform some extent levels. So and regain its original position when removing of load. So removing of load. Similarly, here the shape memory materials, it is ability to remember the previous shape. Previous shape. So by means the changing of inherent property of the material with or during with the stimuli of temperature or etc. So exhibit shape memory effect. We call it as exhibit shape memory effect. So these are the following type of shape memory alloys. Means are shape memory alloys and shape memory polymers and magnetic shape memory alloys. So here the alloys, that alloys means the many number of materials, means more than one materials. More than one metals means metal will be joined to another materials, means nothing but we call it as alloy. That alloy that remember its original shape. So phase transformation due to change in temperatures. Here the phase will be transformation inside the material. So nothing but by due to temperature. So we call it as that. So here austenite phase will be transferred to martensite, or martensite phase will be transferred into austenite site. Here the similar, the original shape of the material means the structure inside the molecular structure in austenite. So again will be changes when increasing of the temperature. So here that the phase will be transferred to martensite. So again will be here the solution means during cooling or whatever the means the temperature difference occurs, so regain its original positions. So regain its original positions. So therefore we call it as shape memory alloy. Shape memory alloy. Here the shape memory alloys have the two states. When cold they are set in original positions. When they can they can be deformed or means nothing but a bend and will not break. So we can observe the image. So when here when the cold they set in original positions. They set in original positions. So they can bend. So they can bend or deform. So deformed will not break. So when heated they return to their original positions. So when bend, so means deform. So here deform after. So when heating, they regain its original position. I will show that one animations. We can observe. So how they means the shape memory alloy regain its original position. See, this is the string wire. So it is regain its original position when temperature increase or potential difference. Sorry, temperature difference. So see here, this is the pin. So this is the hot water, nickel titanium. So the wire pin will be made of nickel titanium materials. So alloy, nickel titanium alloy. So here when dipped into the hot water, regain its original shape. Regain its original shape. I will show another animations. We can observe here. Here the spring. Here the spring will be structured spring. Again will be regain its original positions. You can observe here. Okay, let's move to the next one. Shape memory phenomenon. How the phases will be transferred. So in biological cells are nothing but living cells inside the material. So inherent property means here the forward transformation A to M is exothermic, means nothing but a cooling. Here the forward transformation take place during cooling. During cooling means austenite to martensite will be phase will be transformed due to the in cooling. So in reverse transformation, so here reverse transformation M to A or martensite to austenite. So 2 is endothermic. Endothermic means heating. Heating with the process when cooling. So here the forward transformation take places when heating. This will be martensite phase to so austenite side. austenite side phase will be take places. There is a strong coupling between thermal and a mechanical phenomenon. There is a strong the coupling between a thermal and a mechanical phenomenon during it means the changing of heat and cooling conditions. So exothermic and endothermic process. So here the means coupling between thermal and mechanical phenomenon. You can observe here austenite. So when the cooling, so it will be structure will be changes, the into the phases will be changes into martensite. So here that winted the martensite. So again will be cold at the 25 degrees Celsius. Deformations will be take place. So cold 25 degrees Celsius. Again will be detinted the martensite. Again here the increasing of the temperature, heating, then regain its original position shape. Nothing but hot means here the means heating at 85 degrees Celsius. Again cooling, regain means it will be changes. The phase is changes. Again cold 25 degrees Celsius. The structure remains same. Likewise, your A to M or M to A means that during the process of exothermic and endothermic take places. The shape memory effect means Hurley's in 1950 aluminum and cadmium. So in 1962 nickel and titaniums. So here here William G. Buchler. So US Naval Ordnance Laboratory. So here the nickel titanium. So Naval Ordnance Laboratory. The commercially viable nowadays will be available in the market. Nickel titanium is nothing but a material is in the ductile material. So good corrosive resistance, electrical resistivity. So here another one is a copper base alloys. So here the copper base is the brittle material. So not brittle material is the brittle materials. There are the different applications of the shape memory alloys in nowadays. So you know that aircraft, so and medical and robotics. So aircraft you know that will be always light means will be light material. So means the weight will be reduces. So by using the shape of an aerofoil can be adapted to the extend flight conditions. You can see here the model of the aerofoil structures. The model as shown in figure. The model consists of the slice of an aerofoil which bends so minimize the drag of the aerofoil under the constraint of fixed lift force. So here some lift force will be required to lift the wings. So aircraft. So here the aerofoil shape will be designed by using shape memory alloys. So in the medical applications. So here the medical application self-expanding stent. So expanding stent means rings of SMA wire hold open a polymer tube to open up a blocked vein or blood filters. So you know that this is the Simon filter used for blood vessels interruption to prevent a pulmonary embolisms. So here the person who cannot take anticoagulant measure. So anticoagulant means so here the blood clotting. So here the anticoagulant is in pulmonary filter looks like a anticoagulant. So to prevent the clotting of blood. So you can observe the animations of the self-expanding stents. So here so you can observe the animations here. In a vein will be blocking, so it is removed by the stents or the means veins will be expand. So doing means when where the stent will be inserted, there the veins will be expand. So when due to the high blood pressures or whatever, the vein will be blocked. So it means will be removed by using stents. Here some other application atrial spetal occlusion device, so used to seal the atrial hole in a heart. Even a heart, it's having some hole, there's some disease, heart diseases, so it will be controlled by using, so here shape memory alloys. So this is atrial, means we can observe animations. Here it's having some atrial hole, septal, so filled by using the shape memory alloys. Can observe. So and another one is bone plates. So here the conduct upon transformation to pull the two ends of the broken bone into closer contact and encourage more rapid healing. So here suppose the bone will be so break or miss the crack. So this type of so bone plates are used to quick healings. Quick healing. See another one is orthodontic braces. So you know that the memory shape of the meter is made to be the desired shape of the teeth. This is then deformed to fit the teeth as they are, and the memory is activated by the temperature of the mouth. So depending upon the temperature of the mouth, this string wire in the shape memory alloys, it will be bent or regain its shape, regain its shape of the teeth. And another applications, reinforcement for arteries and veins. So here for clogged blood vessels, an alloy so tube is crushed and inserted into the clogged veins. Here already show that one animations in a previous slide. We can observe here the veins will become blocked. So then inserted the reinforcement of arteries. Arteries. The memory of metal as memory transfer temperature close to the body heat. In body heat, so during the blood heat, the body temperature of the body, so this material gets regained its position, shape of the material. So here the frame for glasses, so this means the glasses can be bent but will return to their shape at room temperature. So this is the frame or glass will be made by the shape memory alloy. So when we application of the forces, it will be bent or deformed. So then will be kept in room temperature, regain its original shape. So these are some typical application of the shape memory alloys. So the next one, shape memory polymers. So polymers that can be heated and bent into shape, when they are heated again, they will return to their original form. Polymers, you know that polymers is that chemical reaction, so chemical chains of a polymer that can be heated and bent into shape. When they are heated again, they will return to their original form. See here, so thermal plastic surgical splint. So when here, these are the some shape memory polymers. See here, this will be made up of the shape of the polymers. When heated off, regain its original positions. So when heat on, again it return to their original form. Can observe heat off. So when heat on, so regain its original positions. See another animations. When heated, the polymer gets expand. Next one is electrochromic. So here the electrochromic materials change their color when electricity is passed through them. So here the glasses, so here the conducting layers, the glasses, there is a conducting layer between them. So here, so when it's application of the electricity or means the potential difference occurs, means this glass piece will be made up of the crystalline material. So here means the crystal You know that liquid crystal. Liquid crystal, this is the it's having some property liquid and crystalline. The molecules inside the molecules will be distract when the non-conductions. When conducting layers means when the potential difference will be on or when you give the electricity, these molecules will be arranged in a manners, arranged in a linears. So that means electricity passes through them, so the color will be changes. Here we can observe the color get changes. Color get changes. This is the normal glasses. When electricity passes through glasses, here the color of the material get changes. We can observe here. This is the animations. So full color electrochromic display. So here when increasing the conduct here, you are supplying of electricity, the color of the glass get changes. Here initially non-conduction, so means in the absence of the electrical supply, so here the material means the light will be scattered. When you are supplying of electricity, so that will mean get linears. So that is therefore it will be colors will be appears. Color change means color changes. So you can observe here also. Here you can observe here by supplying of electricity or potentials charge, you give the potential charges, so that means the color of the glasses get changes. So here the some electrochromic or polymer means means shape memory polymers are means the different applications available in the markets. So you know that. So another one is physioelectric transducers. So physioelectric transducer means you know that. So physioelectric actuator generate electricity when your application of forces. Application of force means that is nothing but stresses. So when application of the force, so on the physioelectric material, so we'll get a potential difference. We'll get potential difference. So using this is also smart material. So you know that here it will be used in a quartz, your wristwatch or whatever. So when application of the forces, you'll get potential difference. We can observe the physioelectric sensor or physioelectric material in your cricket or bells will be glow or ball. So ball given application of the forces, the ball will glow. So means due to the physioelectric effect. So we can observe the animations here in application of the forces. The whole it will be connected to the voltmeter. So here the potential difference we can observe here. Physioelectric transducers. So here the physioelectric actuators generate electricity when pressed. When pressed, so generating of electricity. Similarly, so here the mechanical shock is converted into electricity. So using the piezoelectric element. This is the gas where the lighter. So piezoelectric element, we can observe the animations here. When application of the forces, know that the mechanicals are converted into electricity. Here when this is the gas, this is the lighter. So like in your home, small spark, this is nothing but a piezoelectric element. So here the physioelectric actuators. So here physioelectric actuator generates movement from electricity. When application of the forces or potential difference occurs, so the material get here movement. So this is how the piezoelectric material get movement when application of the electricity. See, you can observe these animations. Here when this application of potential means the voltage will be given to the material, so it will expand. Here get expand, nothing but we consider as a movement. Piezoelectric actuators. So you can observe in a toys or whatever. So let us move to the conclusion of these sessions. Smart material has to behave intelligently, and this may be divided from specialist of structure and reactivities. You know that. So in the first slide I will explain. You know that the smart material is are very sensitive and clever and wise, what we call it as. So here the behave intelligently depending upon your stimulations, what we may given the stimuli, either the temperature or stresses or whatever the magnetic field or electrical field, the material get activated. So the technologies using smart material are useful for both new and existing constructions. So this technology or the smart materials are used in nowadays. So in all field useful for both new and existing new constructions. They have the potential to improve the existing technologies. So here the potential to improve the existing technology. What the technology nowadays is there. So it will become improved and enhancing by using the smart material, and had new functionality to produce products, to new functionality for products. So what are the what are the features we getting in a smartphone or whatever, in the some new technology will be appeared in material or some other products by using smart material. Smart materials are durable, cost effective and high performance materials. High performance materials. I am already told that smart materials are durable compared to the other passive materials or whatever. So it will intelligent, cost effective and high performance material. High performance will be more, so it will performance is more. Shape memory alloys are expected to have wide variety of applications in future. So here, so very wide variety of application is there. So the peculiar properties of the shape memory alloys for smart structures renders and promising area of research in this field. Let us move to the some questions of on smart material. An electrochromic device can change dash when a charge is applied. Second question, a shape memory alloy changes dash when heat is applied. So we can observe, you know that electrochromic device can change dash when a charge is applied. Charge is applied means when supplying of electricity. So here our answer is the color. Answer is color. So here the shape memory alloy changes when heat is applied. Heat applied madadre, so when here shape it get changes. In shape memory alloy shape get changes. Our answer is here when electrochromic device can change color when charges. So here the shape memory alloy changes here the shape when it is applied. So this is the first, you know that. So when electricity is applied to the electrochromic glasses, so here the color get changes. So here the third question, the metallic form of design to observe high autonomous of energy. Explain how this is advantageous for users in cars. So this is the dashboard or the bonnet used in a cars. Bonnet used in a cars. So here how this means, It can be cast easily and used for car bumpers. I am already told that this is used for car bumpers. Cast easily. We can casting it so easily. So therefore used for car bumpers. So the desired shape of the bumper will get by using casting, single casting. So the bumper will absorb energy in a crash, protecting the passengers. So this bumper can absorb the enormous amount of energies, so then protecting the passengers. The foam is light, so the performance of the car may be improved. If the reducing of the weight of the vehicle, so increasing of the performance, so increase the performance of the vehicle, or that getting a mileage or etc. Likewise, so foam is light, so the performance of the car may be improved. And performance or reducing consumption of the fuel will be decreases. So likewise, so to increasing the performance of vehicle. The fourth one, give 3 uses of physioelectric actuators. Give 3 uses for physioelectric actuators. You can observe, that physioelectric actuators, when application of the pressure, stresses or force, it will produce inducing of potential difference or nothing but a voltage. So therefore here it's having a 3 uses. So your mobile or smartphone or your lighter, cigarette, so are nothing but musical instruments. That here cigarette lighter, microphone. So here smartphone. Here some 3 uses of physioelectric actuators. How physioelectric actuator works means how here when application of the forces, so here the potential difference occurs. When potential difference occurs, so here that means it get the physioelectric means the force will be induced. So likewise the physioelectric actuator works. So this is nothing but a physioelectric crystal. So this when crystal, so in application of the potential difference, the alter the structure. So the orientation of the inside the crystal will changes. When application of the stresses, here the orientation of the cell or the crystal get changes. It gives some potential difference. So how piezoelectric actuator means, like when application of forces, potential difference occurs. Force generate electricity. The actuator is connected to a circuit which is powered. Okay. This is our team members. So chairman C. M.S. Devaraj sir, moderator Sir Dr. Madhu B.V. So subject expert Sri Ven Prasad K.V. Subject expert to Malinge Gowda sir. So content developer Mallikarjun sir. So content creator, so Bharat sir. Content creator Vishwanath sir. Content creator Venkatesh, myself. So thank you Nandal. So this is the how the student will be presenting of the professional practice. Suppose if you charge means what are the syllabus will be content, you pick any one of the topic. So you are choosing, get the search the information from the Google or whatever the social media is available or search engine is available. So get the information to form and prepare some scripts or whatever. So what are the material or information, we gather some information and presenting in such a manner. Thank you and all.